Well, good morning. Good morning here in Australia. Hello, everyone. It's Alan Mourgues here at CrowdField. And welcome to today's session. Today, the topic is AI on the ground beneath the hype in oil and gas. Now, this is a very exciting topic for me. If you follow me on LinkedIn, you would know that AI is something that I post a lot about. I do believe that AI at the individual user level is quite amazing. I mean, this is what I believe. And as I posted actually this week on LinkedIn in my feed, I do feel like a kid in a candy store when playing with all these amazing tools and exploring all the possibilities. Now, others may be less impressed. That's just me, right? So the real question, which is valid, is what happens at the enterprise level. So it's all good and fun when playing with these tools, creating code or creating apps with simple English commands or prompts. But can we really scale this up to enterprise solutions and deploy them at scale? Can we really provide reliable solutions with these tools? Or is it just hype? Okay, so that is the question we're going to unpack today. And my guest is Yulia Ziablitckaia. Yulia is a reservoir engineer with a master's in petroleum engineering from the UK with over 14 years of experience in oil and gas. She has worked in development projects in the Middle East, Siberia, Samara regions, and Kazakhstan. And she's worked in both operations and service companies. But more recently, she's the founder of a boutique advisory firm that connects AI companies with the oil and gas sector. So I'm very happy to welcome Yulia to today's session to share her experience in this space with us. Now, a bit of housekeeping as usual. So we're going to budget about 40 to 45 minutes for the talk, followed by 10 to 15 minutes Q&A. Please stay muted throughout the session. And if you have questions at the end, just raise your hand with a little hand icon at the bottom of the screen and wait for my cue before you unmute yourselves, or simply type your question in the chat box. And the session, as I said, is being recorded for later distribution. Now, Yulia is also happy to take questions through the session when she transitions from one section to the other. So same protocol, just raise your hand and I'll give you the cue to fire away your question. Okay, with all of that out of the way, I'm just going to now allow screen sharing and microphone. That's all good. Over to you, Yulia. Take it away.
Hello, everyone, and I'm super happy to be presented today. And let me switch this screen to the one that I have. Please let me know, guys, if you see the screen.
Yeah, we're saying clear.
Okay, perfect. I see the thumbs up. Thank you very much, guys. And yes, Alan already introduced me, and I'm just quickly will say that I started my company in 2023. It's called the TLD Progress company, and my idea is to bridge the gap between the AI technology and the oil and gas industry. So I work with AI tools and vendors, and I help translate tech into the field value. So working both with the AI vendors and with the oil and gas companies. My mission is to make AI useful, usable, and trusted in oil and gas. So what are we going to talk today about? Just a bit of agenda for you guys. So we will talk about where AI can deliver value. So we'll look at the operation, look at the upstream and the downstream. I want to discuss potential risks, data, and security issues that introduced with the new technologies. And the last part, I would like to talk about what actually blocks AI companies from using AI technologies more and from stopping the AI adoption or not going as fast as the other industries. And these are like three major blocks that we're going to talk about. So after each block, we can have a short discussion, or I can answer the questions related. So feel free to keep the questions. Or we have the majority block for the questions in the end if you want to ask something. I also would love you to fill up the Google form in the end and evaluate the webinar. It will be helpful for me and Alan, and we will bring more important webinars for you guys. So let's start. And before we start, let's do some small fun part. So do you see this QR code? If you put your phone and you can open the poll that I have for you guys. So please let me know if you can see the poll. Hey, anyone?
Yeah, we can see the poll and it works. So I just opened the link on my phone.
Okay, and go ahead and answer the question. I would like you to evaluate what you think about the AI mood in the oil and gas industry as per your observation. So this is how the pool will be looking right now. So I would like you guys to answer. See, I'm going to put my question there too. It's going to ask you for the name. Okay, and let's have a look at the responses. So as you can see, we're not so many people here, so statistics maybe not on our side, but still people choose that we're using AI in the daily work. We should be doing more with AI technology, and AI is an interesting thing, but not as urgent. So what does it tell us? What does it tell us? It tells us that pretty much people adopt new technologies when it behaves kind of like a supportive coach. It's personal, it's context-aware, and never judgmental. And this is specifically describes the use of a Gen AI as a technology. So I want you to imagine the AI that remembers the equipment history, able to suggest micro adjustments on your plan, able to reroute calmly and efficiently without alarms and things like this. And we need to build this. We need to have the AI that works the way people work in oil and gas. So following the safety guidelines, taking care of production, producing clear results, and bringing a clear ROI. And these are the things that we are looking for when we're trying to introduce the AI technology in the energy industry. So when we talk about AI in oil and gas in the period of 2024 and 2025, first of all, I would like to reference here the McKinsey study when they estimate that generative AI specifically could unlock additional 390-500 billion. And it shows that AI or that oil and gas companies that moves beyond the pilots, beyond just testing the cases, but into the larger scale, they will get that benefit. They will get that additional value. And if we're talking about all the AI cases, they pretty much can be separated now into a low complexity chatbots that majority probably aware of, to custom large language model for complex tasks like seismic interpretation. We can call it like a straightforward versus their moonshots. The crucial thing for the implementation of AI technologies, like any pretty much technologies in the oil and gas industry, is the operational risks along with the company readiness. We heard a lot that employees are ready, the company is still resistant. And we're going to talk about it in the end a bit more. So let's have a look where AI can deliver value. And to discuss this, I brought you here to show you the three recent SPE cases. These are the real case studies that we presented at the conferences during 2005 or end of 2024, so fresh ones, discussing about how AI technologies, and we talk about artificial intelligence, delivering measurable values right now. And I chose the specific cases, and I will explain you why, and I explain you the progress of using of different technologies, and see what makes these cases interesting. So let's start with the first one. The first one is the case from the Middle East, and this is thank you to the company that I used to work before, and due to my heart. So this is the case about the automated field development project and optimization workflow. So AI was used to reduce development costs while maintaining reservoir pressure and production targets. So the challenges that the company faced in this specific case, they didn't know their optimal number of water injectors. They wanted to maintain the gas cap integrity. They wanted to improve the balance between the water and gas injectors. They had like a reservoir engineer tasks. They wanted to make a good field development project and understand that. They needed to automate it in designing the well trajectories and optimization of economics. So all these things, they've been done by creating a closed loop that integrated the geological modeling, the reservoir simulation, the economic modelation, and proxy modeling. So what AI technology was used here was machine learning. Machine learning was used to reduce the simulation outputs. The scripts in the Python was to connect the geomodeling simulation economics. And as a result, they were able to generate over 250 development scenarios in under 10 minutes. And if one of you worked as a reservoir engineer, that you know like how much work it required to work with the simulation model, with the geological model, to define the scenario, to identify the well placement, it's a work. So to be able to shift it from 41 days to 10 minutes, this is amazing case. And I personally chose this case because it shows that process automation and optimization with AI can bring us such benefits. And the use of AI enhanced proxy model evolves every time with the simulation, learns the solution and identify the best case. What interesting here in terms of ROI in impact, due to automatization and using of machine learning, they were able to save over 300 million USD, which was due to 17 wells reduction. And incremental profit was over 400 and 60% reduction in FDP planning time. So you got your field development project faster, you got your optimal case faster, and it helps you to save money. This is the case. When we look at the cases like this about using machine learning to optimize the field development project, what can move it to the other level with the artificial intelligence technologies is when we start to incorporate live operational data. So for example, the next way to grow in this project is to adjust per well injector on the fly. So start to connect it with real data. Add a level of price forecast, operation risk variables, add simultaneous optimization of energy, the emission, the health and safety risk. Basically, we're moving towards the autonomous field development planning. And this is the step towards that. So this is the case where machine learning was used. Let's have a look at the other case. And this is the case about the use of AI drilling agents. And I know you probably heard a lot of companies and work done in terms of using AI technology, and especially Gen AI technology, large language models in the drilling due to the applicability of the data and the quicker results, because drilling takes like 2 weeks, 1 month, and it doesn't take 5 years like in a plant development project, for example. Somehow my picture doesn't work here, but I will double check on the presentation that it will be. So the objective here was to create a system capable to autonomously manage drilling parameters and improve efficiency and safety. So think about the AI drilling agent that defines what's the best parameters during the drilling, what's the weight on the beat, what's the pressure, what's the torque, what's the other parameters. The AI that was used here was reinforcement learning. So they created the loop when the agent was trained on historical data. They were based on the physics model of well sim. It's a simulation for the drilling, and it was benchmarked against the historical operation. So as a result of that case, they were able to show that AI drilling agent proposed reduction of 58% and performed without safety violations. So there was a specific safety policy introduced saying that like these are decisions that allow it because they must follow the safety rules. And this case is a foundation for autonomous drilling system. What's the room to grow here, in my opinion, is to get out of that sandbox of historical data and to move to a real rig deployment, of course, with a human in the loop, and also move from static data, the historical data, to the real-time data in control. So this is the direction to have that atomic AI agent that controls the drilling. So I chose this case because it shows how the system learns control policies. It shows how the autonomic decision making within simulation, and it shows the future of AI and operational control. And the third case that I would like to show you here is the case actually from, I believe, West Australia, refining maintenance case. And this is the scenario when the large oil and gas refinery implemented a cloud-based AI system, combined sensors, machine learning, and Gen AI. So what they did, they added anomaly detection using vibration and temperature. They did they did synthetic imaging training for file pattern prediction. They used the Gen AI chatbot, they used the LLM agent, they combined a lot of things. And one of the interesting for this case is that Gen AI was able to create synthetic sensor data that helps them for machine learning. So the artificial intelligence were used as a source of the data to feed the other AI model. And this is one of the most interesting cases, in my opinion, because the company was very reluctant on the pilot, but they chose it because they saw their value. Because the previous attempt were not going well until they introduced the generative AI ability to get those cases about the potential failure of the equipment. And we see the results here. They were able to reduce the planning time from 80 days to 1 day. They uncover a new revenue stream. They see the reduction in 80% in inspection cost. And the room to grow here is to scale it up, scale it to the whole refinery, do the real-time testing, use inspection drones, and there's more like triggered by AI, controlled by AI. And what makes it unique, in my opinion, is again the application of Gen AI for training data, improvement in terms of time, planning time from 80 days to 1 day, and application of large language model in that full loop. So if we look at all the cases that we discussed now, then the use of AI technology in oil and gas can be defined into two ways. So the further work, when you work based on these scenarios that are already available, move to autonomous agent, real-time field deployment, include dynamic data, cyber physical integration, all of that. Or we can look about the use of AI technologies outside of the areas that are responsible for production. So for example, AI can be used for the contracts review, for the legal revision, for the standardization, for the compliance to the requirements from the government, supply chain, health and safety campaigns, many things. So before we move to the next chapter, I would like to ask you guys if you have any questions or comments regarding the cases that we discussed.
I do have a couple of questions myself, Julia, if you don't mind. The first one is, these examples you shared are solutions that these companies implemented from within, or they brought outside AI developers or players outside the organizations to test those solutions in?
Different cases, different cases. If we talk about this specific one about the refinery that I was talking recently, this is the AWS solutions were used. If we talk about the case from the Middle East, that was the internal development.
Okay. The other question I had is a little bit more technical. So the first example is the one that is very interesting to me being a reservoir engineer and doing a lot of simulation work. Could you expand a little bit, because I got a little bit confused. First, I thought that machine learning was used to basically analyze the outputs. If you can come back to that slide.
Which one? Which case?
The first example, the water injection.
Mm-hmm. Yes.
Yeah, see, you're number one there, machine learning to review simulation outputs.
Mm-hmm.
But then number 4 is generate 250 development scenarios. So I got a little bit confused as to how machine learning was actually used in this workflow.
Machine learning was used to have a look at the simulation outputs, and the scenarios that were generated was the result of combination of the machine learning with the Python scripts, the optimization and automation.
So let's say, just in plain English, so you get one output, the output is analyzed, and a new iteration is generated from those learnings to create subsequent models all the way down to 250 models. Is that what it is? It's kind of,
yeah, that's what it is claimed. Yes, and if you see here the workflow, it's pretty much like a loop that each parameters gives the fitting for the next one, and the proxy model gets better and better, and then. But this is the case when it was mostly used like the automation. And I saw a question in the chat, and it's a very good question, and I also will talk about it a little bit later in terms of that the industry is pretty much in the automation phase yet, and not in that level of using the artificial intelligence, specifically Gen AI and the agentic AI. Yes.
anybody else with a question before we move on to the next one? It seems not.
Yeah, we're good. So, well, since we talk about the what AI can do, and of course, by AI, first of all, it's always a question like what people define by AI, and machine learning, the reinforcement learning, the Gen AI, it's all part of the artificial intelligence, and you can be in the different steps and using different parts of it. It is correct that machine learning, neural networks, these things been in the oil and gas industry forever, and Python scripting and automation using Python, it's always been there. And sometimes what is a hype is a representation of these things as AI technology. So it's always like that question. But that's why cases that I presented, they progress from the use of machine learning to the reinforcement learning to the Gen AI, and I wanted to cover that spectrum and show you more. But now let's talk about what risks happen when we bring the new technologies, and of course it brings the new risks. So currently, this is the slide from Cyber News, and it shows that the top oil and gas companies, the average security around 72 out of 100, which shows that there is a way to improve the security, and specifically when use of the new technology introduce the opportunity for new risks. Use of large language models, use of real-time sensors, points of the data, it all creates the opportunity for the problems with the data. And how AI affects the attack surface. sensors, valves, smart rigs, everything like smart connected to the cloud. It's a entry points, potential risk points for the cybersecurity attacks. And when we're working on the model level and the large language models that are as good as the data provided, then data poisoning and inputs that can divert the model behavior, that needs to be considered. And the other thing, we always need to remember that AI technologies, more new things, more new application, but they also can be used in the wrong way, like automated phishing, ransomware, supply chain hits, all those things. So if we talk about the potential defense in that, then defense can be the emerging tech, which is again use of the AI-powered anomaly detection on the pipelines or the refineries. And here we're talking about the use of drones, use about the visual recognition, and work with the parameters of pressure, temperature, vibration, all of that. Use of the blockchain to record every transaction or part of the transaction that can't be changed, then specifically important for the supply chain. And you guys probably aware about the zero trust when we need to verify every user and device, and majority of the oil and gas companies, the AI already, like IT teams, they already doing this and making sure. And of course, the importance of data and IP hygiene. And this is related to the subsurface data that must stay secured. And there is a big question about using of open web IPs and the models, or using your own local large language models. And of course, the localized model with the control where this model is stored is better, but we always have to remember about the required resources for that model. And the data, of course, encrypting data, storing data, making sure that people who have access to the data, like, you know, who has access to it, and training for poisoning. For the engineers, like if you work as an engineer, what does it mean for you? You need to guard the data. You need to make sure that data is stored securely, that the share on need-to-know basis, and not sending data via emails. Everybody knows that, but also not feeding ChatGPT with the field data. And I think it's funny to talk about it, but it's a very basic thing that everything that shared, the information shared on the open source language model is available for everybody. And it doesn't matter if it's information, the question, or it's a proprietary thing. So be sure, be vigilant. Validate every AI prediction against feed reality. And this is when the engineering experience comes with the working with the large language models, because if you work with that field, you know the field data, and you can understand if the model will propose the solution that contradict what's common sense for that specific model is, and you will see it that something is off, and you can identify where is the problem coming from, and also have a what if plan. What will happen if the model fails? What if the data is poisoning? What are your actions? So we covered how to keep the data safe. And do you guys have any question regarding the security? Usually there's no more questions on that. It's more like an IT topic. Okay, so since there is no question, now let's talk about what happened when we get that idea, get that interesting pilot project idea of introducing the artificial intelligence technology. We got the understanding how we're going to do it. We're aware of how we're going to keep the data. So we know that we protect the asset. We know we have that curiosity to find the solution. And we know that Gen AI capabilities as memory and personalization, this is that helps us to win. why we're still behind as the industry, because the financial industry, the insurance, the health industry, they move much faster in using AI technology than the oil and gas industry. So do you guys have opinion about that? Because what I've heard in the conferences and talking with the clients and reading, and you probably heard that too. So companies say, we're not sure how to share the data. We don't want to share the data from on the cloud to get the agreement through the IT, to pass it through the IT and the security. It will take months. They say that if we want to use their technology, this should be the best, the most, the almost perfect, the best in the world, and all other adjectives, and it should match the company culture. And if that solution is not to that scale, we as a big company not gonna deal with that, because what if it will not give us the worthy result? And one other interesting thing I've heard is, okay, we will introduce the artificial intelligence technology, like a drilling agent, for example, and it will help us to save the time for X amount of hours. So our engineers will work less, but we'll pay them the same salary. So what's the cash value of that? What's the cash value of saving the time from 80 days to 1 day? Like, how can we justify that? And these are the things that on the executive level prevents us from the accepting the solutions. I put here a group of 5 potential barriers, and you guys will get it in the presentation, so you can have a look here. So whatever is the data silos, cultural pushback, security fears, everything is solvable. When we treat AI as any change management project, we start small, we make it personal, we prove value first, and secure it early. So that's how we move the needle slowly. And if we talk about that data in silos, of course, you guys know that like seismic cubes, model version, they will stored in the different location, different people have access to it, different people aware about the version of the information. And sometimes what is needed is to run that readiness sprint, map critical data, fix high value stream first, and prepare the data before you actually start to use the technology solution. There is what is happening is mismatch between vendors and the field reality. So for example, the generic AI solutions or large language models, they might not be aware of the context. So it requires coordination with domain, SME, and shadowing period when you can train the model. And also there is a resistance from the larger operators to have in-house things rather than go to the external vendors and to give them the opportunity to provide the solution. Or external vendors may be not aware of the specific of oil and gas industry, not understand the importance of the certain things, so they have to learn that. Again, we're talking about the ROI business case. It's like, what is this? What does it mean that you save 2 times a week for the engineer? Like, what's the value? So we always need to tie any pilot to the smart metrics and to publish the results fast. And of course, there is a cultural resistance about the what is that technology, what's that AI solution, how the job was done, like what Alan was asking specifically now, like what exactly was done, was it the outputs, how they were used. So you need to clearly understand what's going on, what's based for that specific decision. And coming back again to the security, IP concerns, who owns the model outputs, what can be introduced, and so on and so on. So these are the things that leads to that resistance and to slowly moving process of accepting the new technology. And one of the interesting things is the ethics and accountability. So, for example, if AI making a bad decision, is it a bad AI, or it's a need to fix the data and review the objectives and oversee the thing? Or if AI is making a good decision, is it a good engineers that needs to be rewarded, or is it a good IT team that needs to be rewarded, or who takes the accountability for the model? So the ethical consideration in AI deployment is always talking about the data privacy, the clear ownership of the projects, and the importance of human in the loop and decision-making process. So 3 things that I want you guys to remember out of this is that every AI effort needs to be tied to clear operation metrics. So either it's the time saved or number of wells reduced or NPT time avoided, decision made faster, and how does it translate to the money. The second thing is to secure first, scale second. So first we learn how to secure the data, and then we move into expanded pilot to the other fields. And the third, and I think it's more important, is that adoption goes in micro steps and trust. And when you have partners who speak both AI and the field operation, this is when you can work with that faster. And talking about that, what I can help with, I can help to look at the opportunities, to define data and security readiness, to look for the pilot and vendor match, and work with the team upskilling. And here's my contacts. And if you guys want to continue that, we can always book a discovery call. So thank you very much. I would love you to follow me on LinkedIn and fill up the feedback form. I'm going to send it to the chat right now so you have it, but I would like to open the floor for questions.
Thanks, Yulia, for that. I think definitely a lot of food for thought. I did like your slide with all the barriers. I do sense on my own end all the difficulties to get teams and companies to get excited about the possibilities that these tools do offer. I think it's important that that comment is not a question, but a comment that Alessandro left on the chat. I think it's a very important distinction to be made, which is, agent and AI. Now it's ubiquitous in our language. It's everywhere. Agent here, agent there. A lot of hype and excitement. But really, what we're talking about at this stage, the industry is not quite there yet. We're talking about just automations and simple glorified workflows rather than true autonomous agents. So we are yet to see proper AI solutions deployed at scale at the enterprise level. As I said at the beginning, what I've seen at least, and I'm keen to see what others feel about this, is I think at the user, at the individual level, this is amazing, but at the enterprise level, it's not quite clear yet. So the examples you did provide are good ones, because those are, enterprise pilots or solutions at the enterprise level. I did like, again, because I'm a reservoir engineer doing simulation myself, your first example on the water injection. So I would love to see more examples like that, particularly in subsurface workflows. I think Alessandro is raising his hand. Take it away, mate.
Thank you, Alan. Thank you, Yulia, for the presentation. It's always nice to hear from people who are dealing with the problem on the daily basis. I have one comment, actually two, but in my opinion, the biggest challenge is usually related to the data. And I believe that one thing that is usually overlooked is the application of AI to the data mining. In my opinion, all...
You muted yourself, Alessandro.
Yeah.
My apologies, I didn't unintentionally. I don't know what you had, but what I wanted to say and to share is that in my opinion, the low-hanging fruit is in the data mining space. as far as an enterprise development. Deployment, because fundamentally all these big enterprise, and I'm talking by experience because I was doing pretty much your job till a few months ago, is the data. The biggest challenge is because we want to apply AI machine learning model to data that they are inconsistent. There are a lot of challenges. So in my opinion, the entry point for a enterprise deployment must be the data mining. Once we are able to sort the data, then whoever is involved in AI machine learning, we will boost its credibility and we will be able to take the next step. Just approaching with the hope that we can start deploying machine learning model without solving the data problems, it will be a really a big challenge for me.
Yeah, that's absolutely correct. And this is what everybody is talking about, is that you need to prepare and standardize and clean the data before you can train any model on that data, because otherwise, how are you going to do it? What the results you can do? Well, how reliable those results can be. So you're absolutely correct on that. And the data preparation, the work with the data, it's what is that big thing that it needs to be done in the beginning before the solution even started. And that's why we always recommend to start on this smaller project. And so you're dealing with that smaller pool of data before introducing it on the enterprise at the company level. So yeah, thank you.
I want to thank you, Yulia, for coming on. Definitely interesting. A lot of food for thought, like I said before. This is going to continue to grow, whether we like it or not. So we better ride the wave and stay in communication with all these developments, which, again, from my personal perspective, I think it's amazing. It's just a matter of how to scale this up at the enterprise level. All right, I think we're just about out of time. Thank you, everyone, again for joining today. Like I said at the beginning, the session is being recorded for later distribution. I will post that feedback form, Yulia, you have for us, as well as part of the notes on that YouTube video on our channel. And thank you, Yulia, again for the session, and thank you, everyone, for joining. That's a wrap.